Hi, welcome. Let's start the session. Welcome to an introduction into observability, and today I choose to focus on Spring with Micrometer because Micrometer really integrates well with Spring and it's a nice way to get started. But I think there's also not the possibility to do an observability talk without talking about OpenTelemetry. So there will be also some parts around OpenTelemetry. It's a project from the CNCF and it has a lot of traction. We will find out later a little bit more about it. Before we start talking about observability, maybe a brief definition. What is observability? I think often it is a little bit confused with monitoring, so looking closer at our systems, looking closer at the application. Of course, it is part of observability, but mainly the idea is when we talk about observability that we understand our system state based on outputs we have. And for example, if we look at this as our system, maybe that's not the desired state of the system because we wanted to have all these same colors on one side of the cube. So based on the outputs that we see, we will then start to understanding the problems, but also we will get a notification based on if something is out of order. So who am even I and why I'm talking about observability? I joined last year a company called Fiberplane. We are a small startup and we build tools in the DevOps and SRE space, mainly a notebook to collaboratively debug infrastructure. And before I have been working with Camunda, more on the microservice orchestration side. And for me, the switch was kind of interesting because I also feel, especially when we talk about the step of making systems observable, it's not the responsibility mainly of one team. It normally means observability needs to be implemented in various teams, especially if we talk about applications, because it's always the question who is responsible for instrumenting application code. I don't think there is a good answer to it, but I think it's an interesting discussion. Besides, I love ice cream, so today was already a good day because I had ice cream, and this will be also later a little bit part of my demo, so there will be ice cream here. So let's start with the output data I mentioned as an introduction. And if we talk about it, normally we talk about telemetry data, and there are three types that we are mainly interested in. And the first one is logs. And I think we all know logs. If we develop, that is a thing that our system talks to us. We understand what's going on. We see error messages. We see other error messages, but we understand basically the outputs and we can work with that. Also in a log, here as an example, you see it highlighted, we can get the information how long something is taking. So in this case, we see some nanoseconds for a certain call and we see, oh, okay, it's a number. But that number alone doesn't really give us information if that was a long call or a short call. We need to compare it to other values that we have. And that's why we need the second type of telemetry data. That is basically metrics. And metrics is the accumulated number of things over a certain amount of time. And for example, now what we see here is for a certain function, the request rate, and we see how often this function was requested. If we would go for latency, we could also understand now, when we stay with the example of time, how long normally this call takes. And then based on the number in the log, we can understand if that particular call was a call that took longer or a call that took shorter for us. And then also understand maybe the reasons behind it. But to understand the reasons behind it, there is a last type of telemetry data that is important, and that is tracing, or traces. And the idea here is that normally our systems, they follow a causal chain. And if we see, for example, a call takes longer, we might want to investigate which route the call has taken. So we want to understand maybe the different service invocation that has taken place. And especially if we are in distributed systems, that gets quite interesting because we don't stay in the boundaries of our service, but we also cross boundary, look into different services and look into the traces. And one trace normally consists multiple spans, and then they are nested and you see the causality, and based on the causality, you can then maybe have further information why the call took longer. So you see all those three types of data are necessary to understand systems and to be able to get more information. One of them alone normally doesn't really give you the best insight. Well, you get already insights, but maybe not the full picture. And because systems are not only our applications, I just like to mention here that it's not only the application code that we need to monitor, but also when we talk about service invocation and especially tracing, we need to think of the communication patterns we have and the service invocations. So if we are in a very microservice setup, we would probably have a message broker and our services would be very loosely coupled. And we need to make sure, if we want to have tracing here, that we propagate the context through the message to the next service so it's not getting lost and we can see the full stack trace. The other part when it comes to observability is not only the services and the service invocation and those parts, but obviously a different layer. We run our applications on the infrastructure. And if we look at Kubernetes, we also get a more complex scenario here. So we might have our services in containers. We put them into pods. They run on different workers. Maybe some of them have a sidecar attached, all kind of connected through the Kubernetes master. And that is a different part of the system that needs to be observed. But I'm not talking about that. I think Matthias is having a talk later today, focusing more on those parts of observability. But yeah, just want to say this is the full picture when we want to observe systems. So let's come back to the application layer. Let's see what we can do here. And I think it's quite simple because we have our application and we need to get logs, traces, and metrics somehow out. So that's a process where we instrument the application. And then we use that information and we start storing that in an observability data backend. That could be, for example, for traces, Jaeger or Zipkin, but it could be also Prometheus for the metrics. Then normally what we do if we stay in this open source world is that we can use those backends also to visualize our data. But because we have all different backends, we don't have the unified view. And that's why we often put on top of all those data backend tools one query and visualization tool, like, for example, Grafana, to have a unified view of what's going on. And that's normally the process. So I promised to talk a little bit about OpenTelemetry because that has really transformed the space currently. It is an open standard defined, or well, it is not only a standard, but it provides also a standard and protocols and SDKs, and it comes from the CNCF space, and at the moment it's a project with the second most traction. And it's a little bit of a revolution because before, you could imagine every vendor had their own instrumentation tools, their own instrumentation SDKs and agents. So maybe you would use some different stuff for Prometheus, some different one for Jaeger, in general speaking. I know that in Java we already had the possibility with Micrometer to deal with that, but for other applications pretty much it was the case that you had different libraries, and OpenTelemetry really has the approach here to unify it and also to define the standard how this data should look like. So you can basically work with one instrumentation SDK or API, and then you can theoretically really easy exchange the backends. So you are not really tied to one of the backends by instrumenting your code. And yeah, so that way it's also vendor neutral because it doesn't provide the telemetry data backend, but only the way of how you would instrument. It comes from Open Census and Open Tracing. They were merged together, so it has a strong background in tracing, but nowadays it's also focusing on metrics and logs. And the nice thing here for Java, we have an auto agent, and we also have Java SDKs and APIs for manual instrumentation. And that basically brings me to the next step. So how can we go now about getting telemetry data out? And the first one, and I guess the easiest one if it works, is the auto agent. So if we consider the auto instrumentation, the idea is in Java, we have an agent that runs next to our application, and we don't need to touch the code base. So in the world, if you have an SRE and DevOps team that are responsible for defining observability, whatever that means, it means that your application engineers are not in the need to touch the application code. And I just make a quick introduction what we are going to see now. So I'm going to use the auto instrumentation on a Java service in a minute, but maybe just showing you this to understand the setup. I love ice cream, I said that already, and I first thought I built an ice cream factory, but I couldn't really wrap my head around the logic, and now I decided, wait, I also have a hard time choosing ice cream, so the flavor, I built myself an ice cream recommendation service or system. So I have some input data that I give to that service, to the input service, and then based on the location, I need to get some geodata, the longitude and latitude. I pass that through to a weather service. The weather service gives me the weather for the location, and finally, of course, every good demo has AI. I call ChatGPT and ask it with all the components what flavor of ice cream I should get. and all connected through Kafka. So they are loosely coupled. They have the message communication. So let's go quickly into the IDE and into my spaghetti world as well. But that is the wrong one. That is the weather service. It's not working at the moment. So what I can do now in the scenario of using the agent, I have installed it. It lives there. I defined the place where it lives. I hand in the name of the service. I define the endpoint here. In my case, it goes to this endpoint. That's the standard. Normally, there sits an OpenTelemetry collector, but in my case, there is Jaeger. So with Jaeger, I don't need to transform the data. I can immediately work with it. I have the protocol. I only export traces. I don't do something with the metrics for now, and I just give it a shot. And perfect, it's starting. I go to my front end, so that's the input data that I'm providing. I connect now here, so we have my name, we have the location, I'm in Zurich. Diet restrictions, I tried that out multiple times. I thought we can be more creative. I choose I love Gruyere, so I love cheese. And my mood is adventurous, so I send it, and hopefully I get soon a result. Takes maybe a few steps. Yes, and here we have Dear Nele, based on your adventurous mood, your love for Gruyere, and considering the scattered cloud weather in Zurich, we recommend you try the caramel Gruyere cheese ice cream flavor. This unique blend will satisfy your cheese cravings while giving you an exciting new dessert experience. Enjoy. So, well, I think the hard part will be now finding this ice cream shop in Zurich that has this ice cream, but yeah, maybe, you see the idea. I now have Jaeger here running as well, and I should now see the trace. So if I go to the weather service and I go on finding the traces, I'm interested particular in this one here. So this one has the 9 spams, and of course, I also instrumented the other services. I'm just showing that now with the auto agent for Java, but I do get the information here. I do see that my Kafka message is instrumented. I see here the consume basically, and here I see also the send. I think there is some caveats that I found out when working with auto-instrumentation. This one is just working fine and it's doing what it's supposed to do. But I also have 2 other services here, and 2 services of the 4 are in Python because I wanted to build a polyglot system. And I found out in Python, yes, it does a thing. It is giving me the traces, and it's giving me the Kafka traces, but there's one important step that's missing, and that's the context propagation. So in order for the traces to be connected to one trace, you need to propagate the context. Basically, you need to have the header in the message that is a parent trace ID or trace parent ID. And within that, you have the trace ID and also the span context ID. So to build the nested span. And it's not a problem because you could potentially also go now into your Python application and manually instrument it, like it's the case for the other one, for the location service that is within this trace. But here again is like the auto instrumentation in that case didn't work out of the box, and you still might be in the situation that you start touching the code base because you need to propagate context. You need to make sure that that your trace shows up correctly. So I think that is maybe a little bit the downside of the auto instrumentation. Theoretically, yes, it works out of the box, but maybe not for everything, not for all frameworks, and not for all languages you have. But I think it's a great start because coming from nothing to having this already, it's great. So you get some insights into what is your system doing and how is the causal chain. You also get some metrics there. So I think the agents is a good start where you can start if you haven't. So yeah. Summing this up, we saw there was no code change needed, so no one needed to touch the application code. There is a wide support, especially with the Java agent, for different libraries and for different frameworks. And we have the so-called out-of-the-box observability to maybe get started. But what if that is not enough? What if we have frameworks that are not supported, and what if we need some business logic also that we want to include in a span, because only if we have also business logic, we might understand fully the picture. Well, then we are at the space to talk about manual instrumentation. And also the SDKs and APIs from OpenTelemetry exist, but personally, and that's maybe just me, I think Micrometer integrates better with the Spring components. Also, if you work with native applications, with Micrometer, that tends to be a little bit easier. So I choose to present now the manual instrumentation with Micrometer, also because I know that a little bit better than the OpenTelemetry SDK, but theoretically, also OpenTelemetry provides something. And that is from the Micrometer homepage. So they really think, or they really would like to think themselves as like, if you think for logs, you think SLF4J, but you think Micrometer for observability in that space. You have a single facade, and it's also the approach. You instrument your application once, and you have different exporters in Micrometer that can work with different backends. So you can push it to Zipkin, but you could also push it directly to Jaeger. It's also compatible with OpenTelemetry, so you can also put your data into the OpenTelemetry collector to work with that quite nicely. The heart of, I would say the heart of Micrometer is the observation API. That is the one API you need basically to get traces, logs, and metrics out of your system, out of your application. And idea as well, similar like what OpenTelemetry says, instrument it once, but get out all the benefits. For the observation API, or in order to create it in plain Java, you would need a registry. And in the registry, you can hand in the configs and also a login handler, how to handle it. And based on that, you can then start, or you can create an observation. And the observation can then observe things in your code. And the observation has a very simple life cycle. It gets started. It can get stopped. You can open the scope multiple times. So you can also have nested expressions in there. And yeah, there's also the possibility that there is an error. But that's a simple life cycle. It works best in a Spring scenario if some of this is taken care in terms of registering beans and stuff. If you work with actuators, so if you have the actuator dependency within your Java project or Spring project, you get some of that functionality out of the box. And yeah, let's go back to spaghetti eyes. Let's see how that looks in the IDE. So I stop for now the weather service. And yeah, now we go a little bit into the code lines. So the first thing that I have is I have Kafka messaging. And if I also want to have now instrumented my Kafka messages, I can go, for example, to the consumer config and yeah, I only commented out. I was a little bit too afraid to live code, so sorry, I'm just commenting in now. But I add to the consumer factory the listener, and within the listener, I can hand in the meter registry from Micrometer. And then also I set the observation enable to true on the container factory. And that basically takes care for me now to instrument the consuming messages that I'm getting. I'm doing the same for the producer. So here I'm also having the factory where I add the listener, and I enabled it here as well for the template to true. And now I also have that enabled. And I think what works nicely is that even though I'm now doing kind of a manual implementation of observability, I'm not really changing a lot of code here to make that happen, to make that change. The other part that I can do is now I can also use the library and use the observation to create own observation spans. So for example, if I go into my domain here and the weather fetcher, I can, oh no, I don't have it here. Sorry, I have it in the Kafka handler. What I wanted to show, I can use the observation here. I create one, basically not started, and call it consume weather, and then I can work with it through my code, and I can say even here I set an observation event. So I have here the weather info is created as a normal or additional thing I'm creating, I can add values here. I have high cardinality values and low cardinality values. In a case I add a low cardinality value, that means basically my key cannot take that many different options. I also added to the metrics. High cardinality values would only end up in traces. And yeah, in the end I stop the observation. And if we run this now, whoop. Just do it from here. And if I go again here, maybe I change the city. Let's check the weather in Berlin. I'm from Berlin, and maybe I don't have any diet restrictions for now. Should also work to see what's coming through. I see there are clouds in Berlin. Lemon basil sorbet, also nice choice. Going back to Jaeger, now to the weather service. See the traces, and yeah, I mean, I see one span more than I had before, and that's basically the internal one that we've created. So that is the one where we also propagate the weather here, where we hand in the high cardinality value, and also, yeah, where we instrumented this for the consume weather, or is it still the old one? Just wondering. Should be this one. And yes, but yeah, I handed in I think the weather as a parameter that was not there before, but basically the idea is the same. So I can also do that and get the same traces if I instrument that. I can even do more now. I mean, I have the actuator. I have the actuator in the dependencies, and so I can now also go to the actuator and see here metrics created for me. Even go to the metrics tab and see different things here available from the metrics side. I could, in the next step, what I'm going to do is I want to expose them to Prometheus. So in terms of Micrometer, what I need to do is basically I need to include this dependency about the registry. So I can also provide an endpoint for Prometheus. That is the next thing. So if I go to the application, stopping it, going to my POM file and just place that and reload. Perfect. That's the one thing I want to do. So I also want to be able to have metrics, not only my traces anymore. And the other thing that I can do with, if we don't want to start observations in code, and if we really want to just have a annotation, we can also work with that in Spring if we include aspects. So we can give here, or we can use here aspects in a bean, and we can hand in the observation registry with a simple logging handler. And by that, what we enable now is that we can use an annotation over our services. So if I go to the weather fetcher, if I want to have an extra observation, I can only say here at observed weather fetcher service, and that already enables me to get some information. Cool. Let's try that out. Looks good. Let's just do one more ice cream recommendation, maybe this time London. And maybe I'm more excited in London. Just sending this, but let's checking in the meanwhile, because now we should see, because we included the dependency into the Maven project. So we see now this endpoint here for Prometheus. And if I go to Prometheus, to the endpoint, I actually see here all the metrics in a format that are digested for Prometheus. So with Jaeger, we basically pushed them, we send our traces. With Prometheus, it's the other way around. So we provide the endpoint with this metrics, and we put Prometheus, or we installed Prometheus to pull from that endpoint to put it into the Prometheus backend. But that is working. And also what I should see now is, because we instrumented the, let's see, we instrumented the weather fetcher, or we used the annotation over the weather fetcher. So now we can also see here that we create metrics from the weather fetcher with the annotation that we used. So in this case, because we just did that, we called it now once by having the ice cream query. And now we have the count of 1, but we can also include that now into the metrics. And also this should now show up somehow in the tracing. So we should also hopefully see that the weather service has an extra span. Before it was 8. So now I see here the weather fetcher get weather condition, and that comes basically from the annotation I put over the weather fetcher. That's all good. Now I already have Prometheus running. And what I can do now, obviously, is that if I put the metrics into Prometheus, I can also do some queries and some analyzing. I think the caveat here is that if you put your traces into Jaeger, you see something quite directly. With Prometheus, you need to learn a little bit of this language to query your metrics. It's PromQL, and I don't find it super intuitive. But yeah, it works. Like, let's see if that works. So now we see here the requests for a second, or the HTTP server requests, and the status with a status code 200. I also see here from the targets that I've connected the endpoint basically to Prometheus to get the information. Okay, perfect. That is wrong. Sorry. Coming back to the slides. So what have we seen with the manual instrumentation? What can we do? We can basically create the spans and metrics according to business logic. So, well, we can, on the one hand side, instrument parts and hook into Spring components like, for example, Kafka, with adding listeners and handing in the meta registry. That's quite nice, but we also can start our own observations with our own business logic and include more value, for example, in spans and metrics. That will help us, again, in understanding the system better and also understanding the system better into business needs. The downside of it is, depending how much you want of your business logic, you need to have the application code to change. So there is no way around that, especially if you start building your own observations, you will add to your application code. And I think that is an interesting discussion, because I think for some organizations and companies, it's not a problem, but some companies do have the problem that an SRE team or DevOps team wants to make systems observable, and the developers on the application end, they don't want to change the code. And then you are in a conflict situation, or then the question often is, yeah, but the observation team should change my code. Well, we've talked about that briefly, in terms of, like, you've seen my metrics in Prometheus and we've seen the traces in Jaeger. There are other observability data backends where you can store certain stuff. For logs, for example, you have from Grafana Loki and Logstash from the LStack. There's another tool for metrics. I haven't tried it out. It's called Graphite. For tracing, you have Zipkin and Jaeger, the most common ones. And if we stay in the open source world, you obviously have, for the combined view and visualization, Grafana and Kibana, where you could bring all together. And that's not the full story. I mean, that's a story if you consider open source tooling, but of course nowadays you can also buy observability suites where you can store all the things in. You have also the visualization in there, but then basically you pay of what you store. There are also some interesting discussions how people want to move away. There was an interesting talk from Trade Republic, I think 2 weeks ago at a meetup. They moved away from one of those observability suites to work only with the Grafana stack. So they moved to the open source side of things to be more in control of pricing and what they store, and also to be in charge of their own observability stack. Of course, if you of course, well, I mean, it's a trade-off. As in a lot of cases, you can buy this one suite. You don't have that much work. But if you start building up your own stack and having all those systems running in parallel, of course, you have there someone to maintain and to install and to provide that for your organization. There's a last thing I like to outline in this presentation, and that's something that we've been working around, or we wrapped our hand around Fiberplane like a year ago, and we thought, let's focus on metrics a little bit more. Why? I mean, I think there were two reasons why we wanted to focus on metrics more than other things. First of all, it's the cheapest way to store information about your systems. So we thought, let's look what is possible. And the second idea was looking at how people were using our tool and querying data from Prometheus. We found sometimes it's very hard for them to understand PromQL, and sometimes even though you have the information because you instrumented your code, it's maybe not so easy to get that into your Prometheus dashboard. And so we decided to build a library around metrics that helps you with creating the PromQL query for you as well. And the Java version, interesting enough, builds on top of Micrometer. And the idea is quite similar in terms of instrumentation, but it's like an abstraction layer, so it does a little bit more things for you. So you instrument the application functions or methods, and from the methods you get latency, error, and request rate. So that are the three things we are interested in, only based on the methods. And it uses Prometheus as a metric backend, so you still provide that endpoint at your application. Prometheus pulls it from, and you store it in Prometheus. On top, we built an open source tool we called Autometrics Explorer to give you some insights specifically into that. But we also have some Grafana dashboards that you can use besides of that component, where you can also get insights. So that's the last thing actually I want to show in code. And I have the dependency here.
So the file is longer and it has a lot of blocks. So here we're just spin up the data, defining our test path, training path, and then
just putting it in, and I just want to outline it at one example. So in terms of my application, I have to enable it here. Oh, you're not. Come on. And then, for example, if I want to use that now over a Kafka handler or over a method here, the listening one, I can basically enable this annotation here. Perfect, doing the trick. And now I can rerun the application. Doing this thing, I mean, let's do one more request. Let's change cities. We now know that there are broken clouds in London as well. Maybe we have better luck in Barcelona with the weather. Sleepy, well, why not? I'm also feeling more relaxed now. It's going to the end of the presentation, so also that is true. Let's see if it's doing something. But yeah, the important part I want to show with the Autometrics things that we are trying, or well, it's open source. We just played a little bit around with that. If I go now here, I have a plugin. Oh, there's something happening, and that doesn't look completely well. But yeah, I mean, maybe just focusing now on this part here, there is a plugin available in IntelliJ where you basically see all these three types of data. And the nice thing here now is if I go to the request rate, it opens for me Prometheus. And basically that's the part what I mean. It writes a query for me. So I don't have to go in there and write this to get the information of the function, because we know what types of label we create under the background. We know what the query looks like. And it should not be empty, but yeah, I mean, that's the one point here. But you can imagine if you have that running, you would also get a nice graph over time, how often this function is called, how much errors you have, and also the latency information is in there. And it was a way for us to understand quickly what's going on in applications. We use that at our own Rust implementation as well to get quick insights into the services. And we also use it to set SLOs. So it's not in the Java version, but it's in the other versions, where you can also define basically server-level objectives in your code base. For example, you can say, if my calls go under a success rate of 99%, please alert me, using the alert manager of Prometheus, triggering an alert in Slack, for example. That's basically the way how we use it internally. Yeah. And if you have a little bit more of data in the Autometrics, that is from the beginning of the slides, but it's also the Autometrics Explorer, the front end that we built. So then you, of course, have a metric graph where you can see the request rate, where you can see the error rate and also the latency. Here, probably we do have some problems with the error rate. Maybe we want to handle that. The other thing that I found super fascinating and the idea, unfortunately only working in the service context, is that even though if we only have metrics, we can create call graphs. We can create a label for function that has been called by other functions, and based on that, we are also able on that metrics or on the side of metrics to generate call graph, the idea of a call graph, without storing traces and spans in our application, but only using the metric information. But yeah, a little bit the downside, because it's only available inside the application context. If you have distributed systems, there is definitely not a solution yet, and we tried a little bit around with that, but we were not satisfied, so we left it at that point. But please feel free to try it out and give us feedback if you think that is useful. Also tell us if it's not useful. And with that, I like to sum up the presentation. And yeah, if we talk about the introduction of observability with Spring, the first part where we spend time is on the instrumentation. So how do we get telemetry data out? We looked into OpenTelemetry's auto agent for the auto-instrumentation, but we also looked into Micrometer and the API that we can use to manually instrument our code base, but also to fine-tune our observability. The second idea, or the second thing we need to learn and we need to know, is the backends. Where do we store the telemetry data? Today we looked at Prometheus and at Jaeger. And of course there are more, but it's a decision where you want to handle and store the information. And lastly, and that came a little bit short today, is the combined view. So thinking of it that you also need to have a tool like Grafana or Kibana to really have the view between logs, traces, and metrics, and be able to drill down in the case that something went wrong. And with that, I like to also give a small recommendation, because last year at Spring I/O there was a really great talk by two people from the Spring team working on Micrometer called Observability of Your Application. And I think the part that is not here in this presentation, you can see really well there, and that's specifically the combined view, how that looks like when you have everything, for example, in the Grafana stack. And yeah, with that, that's it. That was a presentation about the introduction into observability. You can find me on the socials, and yeah, maybe we meet later for ice cream. Thank you.